Hi. Okay, so today we're going to talk about what to do when you have two variables, one of which is quantitative and the other of which is categorical. There are a variety of things that you can do, but we're going to talk about box plots. So kind of a shorter day today, so that's nice. So back to thinking about the median as the center of a collection of data, and how do you measure the spread in this? So just a quick review of that. So here I have some grades on a math exam, and again I don't want to make this all about math exams, but I do want to use that sometimes because I never have to explain to somebody what the numbers mean. So we're looking at 10 grades here, and so the middle number is halfway between the 61 and the 73. Turns out to be 67. And I want to skip over the talk about percentile, but I want to get to quartiles. For any data set, the first quartile is the number that is 1/4 of the way up through the data set, and the third quartile is the number that is 3/4 of the way up through the data set. So when you look at the data set that we were just looking at here, when you look at the data set that we were just looking at, we find, went too far. There we go. When you look at the data set that we were just looking at, if you look at Cal, for example, Cal is 1/4 of the way up through the data set because 20% of the numbers are below Cal, 10% of the numbers are equal to Cal, that includes Cal. So you take, to find the percentile, you take the percentage that are below plus half the percentage that are equal. So that makes 20 plus half of 10 is 5, 25th percentile. So Cal is Q1. Cal's 47 is Q1. And likewise down here, Hortia percentile is Q3 because there's 20% above, and then half of Hortia's 10%. It makes 75th percentile. Okay, so 25% above, so that makes Hortia the 75th percentile. So we're somehow measuring the spread by finding the middle, and then saying that half the people are below this number 67, and here 47 marks the quarter spot. So we're trying to figure out how big is the middle half. From 47 to 86 is the middle half of the data set. From 47 to 86 is the middle half of the data set. We talked about, there's a definition in the previous slide that says 86 minus 47 is called the interquartile range, IQR. But my major idea here is to capture the notion that this tells you how spread the data set is. Where does the middle half of the people sit? Okay. Okay, so I want to talk about drawing this then, and so let's see. I did such a bad job clicking a minute ago now that I'm a little shy. So the 5-number summary is you write down the minimum, Q1, the median, Q3, and the maximum. Again, the 5 numbers are the minimum, Q1, the median, Q3, and the maximum. So back I go, clicking back. The minimum is 34, Q1 is 47, the median is 67, Q3 is 86, and the maximum is 93. So those 5 numbers in some way give you some idea what is the center, what is the spread in the sense that it's the middle half of the data, and then finally what are the extremes. Okay, and I want to draw that. So let's give an example of running through that data set. This is the hard part. I got to manipulate my screen here. There we go. Make that go away. There we go. Okay, so here I am on StatKey, of course, and I'm going to, we'll get to here in a second, but for the moment I want to go up to here. I'm going to write down one quantitative variable, and I'm just going to have StatKey calculate for me the minimum Q1 and all that kind of stuff. So one quantitative variable, and of course StatKey comes up as some default data set, but I'm just going to change it. So I'm erasing this, erase it all. And I am getting rid of the decoration on the screen. Okay, now I'm just going to enter some data. It's just some made-up data. It's not supposed to be especially interesting. So how about if I put in some numbers sort of from 0 to 50? So 3, 7, 15, 17, 19, 25, 29, 35, 37, and 46. Okay, so just some numbers, that's all. It's not supposed to be anything significant. I just put in some numbers. StatKey lays them out for me. They actually seem kind of evenly spread. If you hover your mouse, you see the number pops up. So Stackey laid them out for me, and what I have then is the minimum is 3, the Q1 is 15, the median is 22, Q3 is 35, and maximum is 46. So Stackey found that information for me, and I'm going to show you how to draw that in a second. But the point is that Stackey easily finds that information. We won't usually be doing those calculations. I mean, the median is so easy, and the minimum and the maximum is so easy that often a person just picks it off by eye. But we'll rely on Stackey to do those if asked. Okay, so back I go to the previous, to the slides. Here again, too much manipulation here. I'm going to mess it all up. So there's where I talked about the screenshot of editing data on one quantitative variable to give a person, how to remember. And then, come on, there we go. Okay, so now if you want to draw a picture of those, if you want to draw a graph of the 5-number summary, what you do is you draw what's called a box plot, or a box and whiskers plot. So there's 2 steps to the box plot, and forgive me, I know it's very straightforward, but there's a step that people often get wrong, so I'm cautioning you not to get it wrong. All right, so suppose you have a 5-number summary of 2, 4, 5, 8, and 15. You might notice that 5 is the middle number, 5 is the median, 2 is the minimum. That's not very far between 5 and 2. 5 is the median, but 15 is the maximum. So it's kind of a long way between 5 and 15, comparatively. I want the graph to show that. So what I do here first is I draw in the x-axis evenly spaced. Very important, you draw the x-axis first. Then you draw a vertical bar above 2, a vertical bar above 4, see it there? That's Q1 there, above 4. A vertical bar above 5, a vertical bar above 8, that's right, I did it right, 8, and a vertical bar above 15. That's 5 different vertical bars, and the decoration is to connect those vertical bars. You connect the middle half with a box. That's the box part of the box and whiskers diagram. And then you connect the other 2 with just a line, single line. So that's a box plot. And very important, the key idea of a box plot is that it shows you that 15 is a relatively long way from 5. So it shows you an uneven spacing. So that is to say, the wrong thing, the thing that a person can do that is mistaken. I clicked on the wrong thing again, darn the whole thing. There we go, finally found it. The thing a person can do is mistaken. I will sometimes see people write this wrong. So this is wrong. Don't do this. I will sometimes see people do this on a quiz or exam. They'll write 1, 2, 3, 4, 5 evenly spaced. And then they'll put in 2, 4, 5, 8, 15. Okay, that's wrong. That's wrong because the point of the box plot is to show that 15 is a long way from 5 compared to how far 2 is from 5. So this person has made the mistake of not doing what a box plot is supposed to do, which is to show you the relative sizes. Okay, there we go, back to the slide. Did it right for a change. One of the major purposes of box plots is to draw side by side. Is that you'll have here example is men and women. For you'll have categorical data, men and women, for example, and then you'll show in this case it's the number of push-ups that are done by the women in the class, and the men in the class is just a silly example. I'm going to get Stackey to draw something like that for me. Okay, so let's ask Stackey to draw that. There's Stackey. I got to get rid of this other stuff on the screen. And you remember that I'm in one quantitative variable, so I got to go back. If I can find my arrow, there we go, arrow, there it is. Too much stuff on my screen. Okay. Now I'm on one quantitative and one categorical variable, so I press that, and you see here it comes up with men and women. Of course, you can have it be whatever you like, but I had to come up with men and women, and I want to draw a box plot, so I'm going to click on box plot. I'm going to draw my own. There's nothing wrong with the one they furnished me with, but I'm going to draw my own. So there's the data. It says M0, M0, M0. So you can see that's they've entered the numbers with a label first and then a value. Okay, so let's get rid of those and enter our own, just to illustrate. Come on, come to Papa. There we go. Ooh, they entered too much data for me. I'm not going to enter anything like that amount. Okay, so I'm not going to decorate it. So let's see. I'm going to say M, comma 2, M, comma 4, M, comma 4, M, comma 5, M, comma 8, M, comma 9, and one more for the men, M, comma 15. And for the women, F, comma 2, F, comma 5, F, comma 5, F, comma 6, and F, comma 8. Okay, and I just made those up. They're not supposed to mean anything especially. Okay, so it comes up with a dot plot, and there are the numbers, for example, the 2 5s in the F category. If I asked it to draw a box plot for me, it draws the box plot, and it has a little trouble with the F, but it does a good job with the M. There's the whisker, there's the box, that's the middle half of the data set, and over here's the other end. For example, in the M category, you can see that there's a minimum of 2, there's a Q1 of 4, a median of 5, a Q3 of 8.5, and a maximum of 15. So StatKey finds all that stuff for you. Now let's just explore here what's going on with the F. So with the F, you see that I entered 5 numbers. So I'm asking StatKey for a 5-number summary of 5 numbers. So StatKey, of course, is going to be smarter than I am. It's going to do kind of the right thing and just basically throw up its hands and say, I can't really give you very sensible information there, so I'm going to draw, a sort of a fallback plot. If I entered more data for women, then it would give me a sensible box plot. Okay, very good. So the role, there we go, the role of the side-by-side box plots are to compare, to allow you to compare these two sets of data, in this case the women and the men. And here's an example that I pulled off the web that I thought was interesting, make some point. This is the ages of Oscar winners by gender. So actor is men, of course, actress is women, and what you see here, age, this is in age 30, age 40, age 50, age 60, age 70 kind of thing. So what you see is basically that men win Oscar at a later age. Women win Oscar at an earlier age. Said another way, it's very hard for a woman to win an Oscar at a later age. You often hear that women in Hollywood, there's you get jobs, and then you hit a certain age. Oh, it seems to be roughly the age of 50 here, and it's very difficult to get jobs. What's with the asterisks up here? So what's happening with the asterisks in this graph is that they've decided that these are outlier numbers. They've decided that these are outlier numbers, and they're not going to include the outlier as part of the box and whiskers diagram, because outlier, they've looked at this data carefully and decided that it's an outlier. So they're not going to include that data in the graph. And you see that sometimes, so I'm showing you this graph. One of the reasons I'm showing you this graph is to make that point. Okay, so sometimes you see box and whiskers diagram printed side by side. You could have, I've had 2 of them every time, but you could have 5 or 6 or 8. You could have 1 for each state. You could have 50 of them or some crazy thing, although that's kind of a lot. Sometimes in the box and whiskers diagram, it shows outliers as asterisks or something like that. That's fine. You see that sometimes. The point of a box and whiskers diagram is to show where it is spread out and where it is compact. Don't draw what I drew on the piece of paper. Don't do that. Instead, make sure that you draw the axis regular and then just plot the lines where they fall. Okay, so short day today, so very good. Okay, so we'll see.